guys, this is 4.1a radian and degree measure. Today we're starting with trigonometry. Trigonometry means the measure of triangles. Trigonometry was started with the Greeks and navigation. Now it's been applied to many things, including architecture, engineering, sound waves, ocean waves, oceanography, so many applications of trigonometry. So let's go over some basics to review. So to begin with, I want you to see that initial side is where we're going to start our angles, and our angles are going to end on what's called the terminal side. Now the direction of the angle determines if the angle is positive or negative. So if you move in a counterclockwise direction, we call that angle theta, and that angle is going to be positive. If we start on the initial side and we move in a clockwise direction instead of a counterclockwise direction, theta is considered negative. So that's a little bit about positive and negative angles depending on the rotation. Now looking at radians, radians are a measure of length. So we are going to measure the distance. We're going to refer to the arc as S. So this is the arc length of the circle. We're going to refer to the radius from the center to the edge of the circle as R. Now, when the radius and the arc length are equal, we have exactly 1 radian. The formula for the angle, or theta, then is going to give you the arc length over the radius. So theta is always equal to the arc length over the radius, and again this would be in radians. Arc length, if we wanted to take this equation and multiply both sides by r, the same formula would be S equals r theta. And again, we only use this when theta is measured in radians. So just a reminder, the circumference formula is 2 pi r. So that means there are 2 pi radians around the circle when the radius is 1. So looking at, let's compare degrees to radians. Quick reminder, 0 degrees, you know it's in degrees because you always see this degree symbol. You start at 0 degrees on the positive side of the x-axis and you travel around the circle. A complete rotation around the entire circle is 360 degrees. Now we can quickly fill in what we call the quadrantal angles. These are angles. You can see here then we went 0 to 90 to 180, 270, and then a full circle is 360. In radians, we go from 0 to pi, that's the half circle. Full circle would be 0 to 2 pi. If you take half of pi, you get a half pi. If you go 3/4 of that circle, you're going to get 3 pi over 2 in radians. Now, special triangles have a 30, 45, 60 degree angles. So these are going to be specials, 30 degrees, 45 degrees, 60 degrees. Equal to that in radians is pi over 6, pi over 4, and pi over 3. The reason why is if you were to take pi and look at this picture up here, if you were to take pi and break it up into 6 parts, cut it into 6 sections, then you would get 1 pi over 6, 2 pi over 6, which is the same thing as pi over 3. That's your 60 degrees. 3 pi over 6, which is the same thing as 90 degrees, or the pi over 2, 4 pi over 6, 5 pi over 6, and then 6 pi over 6. So if we break it into 6 parts, we get pi over 6. Those are 30 degrees, 30, 60, 90, 120, 150, 180. If we break it into fourths, 45, 90, 135, and then 180. And then if we break it into thirds, that's 60 degrees, 60, 120, 180. So know those specials in the radians and degrees. Now let's look at what a coterminal angle is. So a coterminal angle means we're going to start in the same place and we're going to end in the same place. So basically, algebraically, you're adding or subtracting 360, or you're adding or subtracting 2 pi if you're in radians. So if we look up here, this is a coterminal angle here. I can get to it going in the positive direction or the negative direction, but you notice that I start and I end exactly in the same place. So we're going to take 130 degrees and we're going to find a positive and a negative coterminal angle. Now your solutions are infinite because you could keep circling around and around and around, but we'll just take the 130 degrees and we will add 360 degrees, and that's going to be the first coterminal angle, which is 490 degrees. Now, if we were to look at what that looks like, then we would see that 130 degrees is going to be somewhere over here in the second quadrant. And so we travel here and we went 130 degrees. Quick reminder, first quadrant, second quadrant, third quadrant, fourth quadrant. So that's 130 degrees. Now, if I were to travel in the same direction, start at the same place, complete a full circle around, and then end in the same place, that's called a coterminal angle, and that angle was 490 degrees. Now let's look at one going in the opposite direction. So if we take 130 degrees and we subtract 360 degrees, that's going to be a coterminal angle. So take 130, subtract 360, and you're going to get negative 230 degrees. Now in trigonometry, the negative is the direction. So you're going to start here on the positive side of the x-axis, and you're going to travel in a clockwise direction, ending at the same place. So you can see here I went 90 degrees, 180 degrees, and a little bit more to 230 degrees in that direction. And so the coterminal angle is also negative 230 degrees. You could keep subtracting 360 or adding 360 to get more and more coterminal angles. So there are infinite solutions to that. The next thing we want to do is look at 9 pi over 2. So first off, I want to make sure you guys know how to graph 9 pi over 2. So what you can do is take 2 and divide it into 9. It goes 4 times. And then you have a remainder of 1 over the denominator, 2 pi. And so what 4.5 pi means is if you were to complete one full circle, that's 2 pi. Another full circle is 4 pi. And then you would go, here's a half pi. So pi over 2 is a half pi. Over here would be a whole pi. Here would be 1.5 pi's, and then back to 2 pi. So if you have to go 4 pi, it's 2 rotations, and then a half pi puts you right here. So we want to know some coterminal angles with this point here. So just looking at it, you could say, well, I know that that's pi over 2. So pi over 2 would be a coterminal angle. And then let's say that I wanted to go in a negative direction. I could start here and come back in this direction. And this would be pi over 2. That's the half pi. You've got pi, and then here is going to give you 3 pi over 2. So 3 pi over 2, and this would be negative because I'm traveling in a clockwise direction. So negative 3 pi over 2 is also a coterminal angle. Now I do want you to see what this looks like algebraically or numerically. So if you have 9 pi over 2, you don't really want to add another 2 pi because that just makes it, you have all of these circles and we're just going to unwind it. So if you subtract 2 pi, you're still going to end up with a positive angle. And we want one positive angle. So I'm going to subtract 2 pi. When you do this, you're always going to get common denominator. So the common denominator is 2. And then you have 9 pi over 2 subtract 4 pi over 2. I'm going to put this in pink because it's positive. 9 pi over 2 subtract 4 pi over 2 is equal to 9 subtract 4 is 5 pi over 2. So there's another positive angle. Let's subtract 2 pi again. So if I subtract 2 pi again, I would get a common denominator of 2. This is 5 pi over 2 subtract 4 pi over 2. So 5 pi over 2 subtract 4 pi over 2 is 1 pi over 2. There's another coterminal angle. These are both positives. And notice when I take and subtract 2 pi again, I'm finally going to get a negative angle. So again, you have to get common denominators. The common denominator is 2. And then think of this as 1 pi over 2. 1 pi over 2 subtract 4 pi over 2. And common denominator, you keep that 2 as your common denominator. And 1 pi subtract 4 pi is 3 pi over 2 negative. And there's your negative coterminal angle. So now let's look at complementary and supplementary angles. These are terms that you learned in geometry. A complementary angle is simply where you're going to add the two angles together and they're going to equal 90 degrees. If you're in radians, it's going to equal pi over 2. A supplementary angle are two angles that add up to 180 degrees or pi radians. So we're going to look for the complementary angle and the supplementary angle right now. So looking at 2 pi over 5. If the problem is given to you in radians, you want to stay in radians. So again, I want to make sure you know how to graph 2 pi over 5. What you need to do is think of this as 2/5 pi. So from here all the way around to here is a whole pi. And from here to here is considered a half pi. And we know 2/5 is smaller than a half. So 2/5 is going to be in that first quadrant. So looking at this, we could say, okay, here is 2/5 pi or 2 pi over 5. Now, complementary angle means that you are going to have theta. So here's theta, and maybe we'll call this theta prime. And when you add those two angles together, then you get pi over 2. So we are looking for both of these angles. Well, we have this first angle. Here's 2 pi over 5 right here. And so now we are looking for this second angle. So how do you do that? You take the whole, which is pi over 2. You subtract the part, which is 2 pi over 5. And when we do that, we're going to get this angle right in here. And those two angles are going to add up to pi over 2. So you always want to get common denominators. So the common denominator is going to be 10. So you'll multiply the first fraction, top and bottom, by 5. You'll multiply the second fraction, top and bottom, by 2. And then 5 pi, this is 5 pi over 10, subtract 4 pi over 10 is equal to 5 subtract 4 is 1. So 1 pi over 10. So therefore, the complementary angle is this angle right in here. I'm going to erase this. And it's going to be pi over 10. And so let me color coordinate here. This is pi over 10, and this one is 2 pi over 5. And when you add those two angles together, you add the pink and the green, you get pi over 2. So those are called complementary angles. Now, we can also have a supplementary angle. So from here to here is 2 pi over 5. And now, let me put this in blue sparkle. We're looking for the angle from here over to here. So this is the angle that we're looking for to find the supplementary angle. So what you do is you take the whole is pi, and you subtract the part that you have, which is the 2 pi over 5. So you're going to take pi, subtract 2 pi over 5. Again, you got to get common denominators. So the common denominator is 5. And then once you have common denominators, it's just like subtracting fractions. 5 pi over 5 subtract 2 pi over 5 is equal to 3 pi over 5. So that is the supplementary angle. So you could label those. This one is the supplementary, and this one over here is the complementary angle. Now let's look at 4 pi over 5. So 4 pi over 5, think of this as 4/5 pi. So if you were to graph this, here's 0, here's a whole pi. 4/5 is bigger than a half. So here's the half pi. So 4/5 is almost 5 over 5. So you're looking at way over here. So as far as complementary, your answer is none. And that's because you're already bigger than 90 degrees, or you're already bigger than pi over 2. So the complementary angle is none. There's not one. But let's explore the supplementary angle. So here's your complementary, or not complementary, here's your 4 pi over 5. And we're looking for this green right here. So how do you find the green? You take the whole, you subtract the pink, and it gives you the green. So the whole is pi, so you start with pi. You subtract the pink, which is 4 pi over 5. You want to get common denominators, so 5 is the common denominator. 5 pi over 5 subtract 4 pi over 5 is 1 pi over 5. And probably most of you guys realized if this is 4/5, this is 1/5 to make up that whole pi. And so answer is pi over 5, and that is the supplementary angle. Let's look at how to convert degrees to radians and radians to degrees. So if you're starting with degrees, we know that pi over 180 degrees is a ratio. Pi is equal to 180 degrees. So you can take whatever your degrees are, you can multiply it by pi over 180, and that's going to give you the radians. And that's because pi over 180 is the same thing as multiplying by 1. So when you take 540 degrees, you're going to multiply it by pi over 180 degrees. Now, something that's nice here is I always remember that the degrees are going to cross cancel, leaving you in radians. So the zeros are also going to cross cancel, and then 18 goes into 54 3 times. And so 540 degrees is the same thing as 3 pi radians. Okay, so now we're going to go and convert. Here's my little tip on how to remember to do this. The degrees will cross cancel. All right, let's convert radians to degrees. Now we're going to just flip our fraction. So we're going to take the radians, we're going to multiply it by the 180 over pi, and it's going to leave us with degrees. I always remember this because we want the degrees to stay, and so they're not going to cross cancel. So looking at 3 pi over 4, if I take 3 pi over 4 and I multiply it by 180 degrees over pi. Now, sometimes the pi's will not cancel, and that's okay. You can still have pi in degrees, all right? But in this case, the pi's cross-canceled, and now we can say 4 divides into 180 45 times, and now 3 times 45 is 135 degrees. So this would be 135 degrees. So 3 pi over 4 converts to 135 degrees. Note that in this case, we multiplied by 180 over pi so that the pi's would cancel. Last thing we need to talk about is reference angles. So this is going to be a really, really important concept. A reference angle, every angle has a reference angle. The reference angle is always positive, by the way, and the initial side of a reference angle is always going to be the x-axis. So here's a drawing. It shows you if your angle is in the first quadrant, that's going to be your reference angle. So if that's theta in the first quadrant, theta would be your reference angle. So let's come down and try that one. 45 degrees. So 45 degrees is right here. And we start on the x-axis and we come here. And you guys, I like to think of forming a right triangle with the x-axis. And now we're looking at that angle starting from the x-axis to the terminal side, and that angle is also 45 degrees. So the reference angle is the same as the angle. But now let's see what happens when we go to the second quadrant. So up here, when I travel all the way around to the second quadrant, we're going to call that angle theta. Well, the reference angle is this angle right in here with those two lines. That's the reference angle. So do you notice I formed a right triangle with the x-axis, and the reference angle is formed by the x-axis and where the angle ended. So if I have 120 degrees, I'm going to start here and I'm going to travel to the second quadrant, and that is an estimate of 120 degrees. Now the reference angle is this angle here, and a lot of times we'll call the reference angle theta prime, and this is going to be where we form it with the x-axis, and there's the reference angle, and so theta prime, the whole, if we come from the starting point all the way to 180 degrees, and then I back it up by the reference angle, then I get 120 degrees. So what's that missing angle? That missing angle is 60 degrees. 60 plus 120 is 180. So basically I took 180, subtract 120, and I got 60 degrees for the reference angle. Now let's look at when the reference angle is in the third quadrant. So let's come back up here to my picture again, and let's travel all the way around to the third quadrant. The reference angle is going to be this angle right in here. And that's because you draw a right angle with the x-axis, and the reference angle is formed with the x-axis and the terminal side. So right in there would be your reference angle. So let's try to do the reference angle for 225 degrees. So we would come here, we would go 90, 180, and then 225 would be exactly in the middle of the third quadrant. So that angle we refer to as theta is equal to 225 degrees. Can you tell me what the reference angle is? That's that angle right in here. And so if you take, notice that we passed 180 degrees. So how far past did we go from 180 degrees? Well, 225 subtract 180 is 45 degrees past. So 45 degrees is the reference angle. The reference angle is always going to be between 0 and 90 degrees, and it's always, always, always positives, just so you know. All right, let's look at the last one. So what happens when we travel all the way to the fourth quadrant? We start here, we go all the way around to the fourth quadrant. The reference angle is going to be this little angle in here. And that's, again, you draw a right angle to the x-axis. The reference angle is formed from the x-axis and the ending side. So let's try 330 degrees. So we would start here on the initial side. We go 90, 180, 270, and then we come all the way up here to 330. So that is theta. So theta is 330 degrees. So what are we talking about for theta prime? This little angle right in here. So the full circle is 360 degrees. So how do we figure out what this little angle is here? Just take 360, subtract the 330, and theta prime is going to be 30 degrees. So I hope that makes sense. I'll call all those reference angles theta primes. Reference angles are going to be really, really important to our trigonometry. So with the reference angles, I would like you guys, before we start using this shortcut, to memorize these specials. So in class, I'm going to teach you the shortcut, which is really amazing to change degrees to radians and radians to degrees. You use the shortcut when you have specials. So let's talk about specials. 0 degrees is 0 radians. 30 degrees is you've got 1/6 of a pi segment, so pi over 6. 45 degrees is 1/4 of a pi segment, so pi over 4. 60 degrees is 1/3 of that half circle, so pi over 3. 90 degrees is half, so pi over 2. 180 degrees is 1 whole pi. 270 is 3 pi over 2, or 1 1/2 circles, or not circles, but 1 1/2 radians. And then 360 is 2 pi radians. It's 1 complete circle around. So I really, really need you to memorize these. And in class on Thursday, Friday, we are going to talk about shortcuts for the specials. So memorize those, and then I will go over the shortcuts. Thanks, you guys. Have a really amazing day. Don't forget to write some sort of reflection about this lesson.